So hello everyone, welcome to this new video. So till now we have discussed in our previous videos we have discussed two kind of parameters. One is Z parameters, impedance parameters, and Y parameters, admittance parameters, right? So now in this session we are going to discuss with one more kind of parameter, very interesting, and yet you can say that this is a bit tricky and you can say that a bit tough, okay, because there are dependent and independent variables consists of both currents and voltages in this case, okay. Which current and which voltage, that is which input current and which output voltage is in which position, if you know that only correctly, then you can solve these kind of problems, okay. So now let us see what is the definition of this H parameters. These parameters are obtained by expressing voltage at input port and current at output port in terms of current at input port and voltage at output port. That is, this is the definition part. In order to understand this definition very well, useful in constructing the transistor models. Okay, this is the use of these H parameters. They are useful in constructing the transistor models. Okay. So here in this case, V1, that is the input voltage, and I2, that is the output currents, these two are dependent in this case. In Z and Y parameters, what we had, either both the inputs or both the currents, both the inputs or both the voltages or both the currents were dependent and independent together, right? But here in this case, one is voltage and one source is current, so that's why it would be very confusing. V1 and I2 are dependent and I1 and V2 are independent. That is, in the first equation we have V1 in terms of I1 comma V2, that is V1 is the function of I1 comma V2, and the second equation consists of I2, which is the function of I1 comma V2, okay. That is, these two are independent variables which are the functions of V1 and I2 respectively, okay. So in this way the equations are written. So now in order to represent this in our functions, in order to represent it in terms of H parameters, like this it is written, okay. That is, V1 is expressed in terms of I1 and V2, I2 also is expressed in terms of I1 and V2, and V1 is equal to H11 I1 plus H12 V2, not I2, this time it is V2, then I2 is equal to H21 I1 plus H22 V2. Okay, these two are the equations here. So similarly, our goal here in this case also is the same, remains, that is, we should be finding the individual parameters H11, H12, H21, H22. So how we can find the value of H11? By making V2 equal to 0, we would be getting H11 as V1 by I1 with the condition implied V2 equal to 0. Since it is V by I, that is a resistance, so we can unit we can represent it as ohms. So this is a short circuit input impedance. H12 making I1 equal to 0, what we would be getting? H12 is equal to V1 by V2. Since these both are voltages, so open circuit reverse voltage gain. Since these both are also voltage, so that's why open circuit reverse voltage gain, okay. Then H21, since both the sources input and numerator and denominator both consist of voltage sources only, so that's why it is represented as voltage gain, okay. Then we have H21. If you make V2 equal to 0, we would be getting H21 as I2 by I1, okay. That is V2 equal to 0, short circuit current gain, because both are also currents now. And similarly H22, when I1 equal to 0, we would be getting I2 by V2. So this is I by V, so the unit here is ohm, and this is the admittance part, that is open circuit output admittance. H11 is short circuit input impedance, and H22 is open circuit output admittance. One is impedance, one is admittance, okay. You should be being very careful, okay. And this is the equivalent circuit part here. If you want, you can note it down, and like this are the four individual formulas for H11, H12, H21, H22 applied with the condition that either one of the voltage or current source should be equal to 0, okay. Then only we would be getting these relations. So hope this is clear. So now in order to make you much more clear, I have one problem in this session related to H parameters, then we are going to wind this session, okay. So let us solve that one problem quickly. So yeah, this is the first problem that is related to H parameters. So in case of H parameters, again we are going to solve these kind of problems using the definition part. That is, I have solved similarly this kind of problem in one problem in Y parameters, okay, if you remember. See here, I've written the set of equations for H parameters, and individually for all the formulas I've written it here, okay, with the implied conditions, okay. So now what you should be doing, this is the complex circuit they have given, 2-port network. In this they have asked us to find the H parameters of the network, okay. So here I am going to again split this circuit into two parts. That is, we have two initial conditions. One is for V2 equal to 0 and another one is for I1 equal to 0. Right. So that's why we would be applying both of the conditions in this circuit. So I have forgot to mention the currents here. One is I1 and I2. Okay. Yeah. So like this you are going to solve. First thing, let us consider the condition that V2 equal to 0. So when V2 equal to 0, which and all are the parameters which we can find? That is, when V2 equal to 0, we have two parameters. One is H11 and H21. So if we put in this circuit, if we make V2 equal to 0, we should be making this short circuit here. Okay. Then V2 would be equal to 0. Simplify the circuit and then solve using mesh analysis, so that we would be getting these two values, that is H11 and H21. Our goal is to find H11, H21. Then after that, after finding that, apply the second condition, that is I1 equal to 0 in the same circuit. Then find the values of H12 and H22. Then complete your problem. Okay. So this is the procedure. Now let us see this procedure. Let us analyze and solve this problem. So first is V2 equal to 0. Rewrite the circuit. So here I have rewritten the circuit here, as you can see, V2 equal to 0, right? So this is V2 equal to 0. I have made this as a short circuit. Whenever, if you want to remove any voltage source, I have told you we should be making a short circuit here. After that, next step is solve the circuit, try to reduce it. You can see that we have one 4 ohm resistor and here we don't have any resistor, but these two are in parallel branches. So what we can do, we can take the equivalent resistance, that is 4 into 0 divided by 4 plus 0, that is 4 zeros are 0 divided by 4, that is 0. So here these two branches completely gets eliminated because we have zero resistance here. Okay. So according to that, now rewrite the circuit like this. That is 1 ohm resistor, 2 ohm, and here we won't be having any value resistor, right? This is 1 ohm, 2 ohm, 2 ohm. So here we have I2 current, here we have I1 current, and this is V1. Now we can name these loops here. One is I1 and one is I2. Okay. So here we have reduced this circuit. Now we should be solving using mesh analysis, and let us see what and all are the equations we get. First, apply KVL for loop I1. Okay. Solve using mesh analysis. Start from V1, outward sign plus V1. Then we have minus 1 into I1. Then we have minus 2 I1 plus I2. Since these two are having the same directions, I have told you multiple times, so that's why it is plus. Then equal to 0. Solve this. V1 minus I1 minus 2I1 minus plus minus 2I2 equal to 0. That is V1 minus I1 minus 2I1, that is minus 3I1 minus 2I2, that is equal to 0. So we have got one equation here. Okay, name this as any equation 1. Okay, so here this equation is not the solution part. We are going to simplify this equation further. So before that, now what to do? Next step, that is apply KVL for the second loop, and let us see what we can get. So here apply KVL for this loop, that is start from since the direction is like this, you can start from this resistor. Here outward sign is 2, minus 2 into I2, then we have minus 2 into this minus 2, then I2 plus I1 equal to 0. So that is minus 2I2 minus 2I2 minus 2I1 equal to 0. So that is minus 2I1 minus 2 is minus 4I2 equal to 0. So here we have solved this equation, and if you observe very carefully, this equation are in the terms of I1 and I2. We don't have any other terms, only I1, I2. And if you observe this part here, that is H21. H21 consists of only I1 and I2 variables, right? For V2 equal to 0, we can find now H21 because these two are having only I1, I2 variables. So now what we can do is we can find H21 by solving this equation, that is minus 2I1. Then bring this 4I2 to the other side, that would be plus 4I2. So now our equation is in form of I2 by I1. So this would be now I2 divided by, bring this I1 to other side. Minus 2 is here as it is, then divided by this 4 you bring down. So that is I2 by I1, we know that what is I2 by I1? H21. Okay, so H21 is equal to 1 za 2 za minus 1 by 2. Okay, like this we have found one parameter, that is H21. H21 is done. Now next thing is we need to find what is H11, right? For V2 equal to 0, one condition is done. Now next is H11. So how we can solve this H11 here? Okay, we can make one change, that is, if you observe carefully, H11 term consists of V1 and I1. Okay, and in the first equation we have V1, I1 and this one obstructing term, that is I2, right? So this I2 now try to write in terms of I1. So how we can write it? Try to write in terms of I1. Just observe these equations here. Wherever we have I2 and I1, I2 in terms of I1, can we solve it? So here this part we can solve it. That is, so here we have minus 2I1 is equal to 4I2, right? So here what we can do is I2 separately we can write. That is I2 in one side and minus 2I1, this 4 if it comes to other side it should be divided. That is I2 would be equal to minus I1 by 2. So now I have represented I2 in terms of I1, that is I1 by 2. Now substitute this I2 in this equation, then what we would be getting, this equation would be completely of the form V1 and I1 terms, right? That only we want, because we need to find the value of H11 which consists of V1 and I1 terms, right? So that change we should be doing. Now I2 we have solved and made it as minus I1 by 2. So now equation 1, what it will be becoming? V1 minus 3I1 minus 2I2 equal to 0. So this was the equation, right? Now V1 minus 2, and what is the value of I2 now? Minus I1 by 2, right? So 2 would be getting cancelled. We would be left with V1 minus 3I1 minus plus I1 equal to 0. V1 minus 3 plus 1, that is minus 2I1 equal to 0. V1 is equal to 2I1. So now we need V1 by I1. So what I will do is V1 divided by this I1, I will bring it to other side, and that here we have only 2, so keep it as it is. So we know that what is V1 by I1? V1 by I1 is equal to H11. So that is equal to 2. So here we have found H21 as well as H11. First part is done. So now apply the second definition, that is for I1 equal to 0. That is, in the main circuit here we should be making I1 term completely equal to 0. Okay. So now let us solve that. Let us rewrite the circuit and solve it. Okay, so for I1 equal to 0, I have rewritten the same circuit here. Okay, I have not made any change. The same circuit I have printed it here. Now what to do is simple mesh analysis you should be applying. That is, write all the equations, and wherever we would be getting I1 in any term, in writing in any equation, just cancel that, because I1 equal to 0, right? So that term only would be getting cancelled. And now let us solve for H12 and H22, right? For I1 equal to 0. We need the terms H12 and H22 in form of V1 by V2 and I2 by V2. So let us see now what we would be getting. Simple, that is, first apply KVL for loop 1. That is, start from this V1 plus V1, then we have minus I1, then minus 2 into I1 minus I3 equal to 0. That is V1 minus I1 minus 2I1 plus 2I3 equal to 0, right? So V1 minus 1 minus 2 is minus 3I1 plus 2I3 equal to 0. So what we will be getting now? 3I1 term, cancel it completely, because we know that I1 equal to 0. So substitute that, and this whole I1 term would be getting cancelled. We would be left with only V1 plus 2I3 equal to 0. So this equation now, name it as some equation 1. Equation 1 is done, name it as equation 2 now. Okay. Now similarly apply KVL for loop I2. Okay. So this loop how? Let us see what we would be getting. That is, we have here so first let us apply KVL for this loop, okay, loop I3, okay, not I2. Let us see what we will be getting. So the equation is, start from this 2, that is minus 2 into I3 minus I1, then we have minus 2I3, then we have minus 4 into I3 plus I2, right? That is equal to 0. Okay, solve this. That is minus 2i3 minus minus plus 2i1 minus 2i3 minus 4i3 minus 4i2 equal to 0. So what we would be getting? This i1 term, again we got one i1 term here. So what we should be doing is, should be cancelling it because i1 equal to 0, right? So now what we should be doing, 4i2 term, that is minus 4i2, then minus 2 minus 2 minus 4, that is minus 8i3 equal to 0, right? So we got this equation here. So now our goal here was to find the values of, which values we need to be finding. One is V1 by V2 and one is I2 by V2, that is H12 and H22. But now we have got these two equations now. So now what I'll do is, before applying KVL for this loop, that is loop I2, you should be applying KVL for loop I2, right? So before that, what I will be doing, one change is, if you observe this loop very carefully, if we apply KVL, which terms and all we are going to get? That is V2 term is there. Then if we continue the equation here, we would be getting 4, which is between I2 and I3. So V2, I2, I3, right? These three variables we would be getting in one single equation. But our goal is that I3 is obstructing us, because I3 we don't need. So we need V2 and I2. In order to calculate H22, we are having two variables V2 and I2, but I3 is coming in between. So this equation we have already written. So what we can do is, this equation represent I3 in terms of I2 using this equation. That is what we would be getting, minus 4I2 is equal to minus 8 would be plus 8I3. So I3 would be equal to minus 4I2 by 8, that is 1 by 2. I3 would be equal to minus I2 by 2. Right, so this I3 value, after putting the equation in loop I2 KVL, that I3 term replaced by minus I2 by 2, so that we would be getting the complete equation in terms of I2 and V2, so that we can be solving for H22. Okay, so that's why now apply KVL for loop I2. That is, start from this V2 here, V2, then we have minus 4 into I2 plus I3 equal to 0. That is V2 minus 4I2 minus 4I3 equal to 0. V2 minus 4I2 minus 4 into, substitute I3 value as minus I2 by 2, that is equal to 0. 2 1s are 2 2s are. So V2 minus 4I2 minus minus plus 2I2 equal to 0. V2 minus 4 plus 2 is minus 2I2 equal to 0. If you bring that to other side, it will be plus 2I2. So now we got V2 and I2 terms. So we need I2 by V2. So I2 divided by V2, and here we have 1 already. Then this 2 you bring it to other side. So what is I2 by V2? That is H22, right? That is equal to 1 by 2. So 3 of the parameters we have found. H22 is done. Now we have left with only H12, right? But H12 consists of which terms? V1 and V2, right? So how we can solve this equation here, if you observe? We can solve for H12. It consists of V1 and V2 terms, right? So now consider this equation here, equation 2. That is V1 plus 2I3 equal to 0, right? So now I3, replace it by again this term, that is V1 plus 2 into minus I2 by 2. So cancel these two and we would be left with V1 minus I2 equal to 0. But this is not now, this I2 now we should be representing in terms of V2. So how we can represent it? If you observe carefully here, this equation here, okay, we can represent I2 in terms of V2 by solving this part. That is, I2 you keep it to one side, then V2 bring it to one side, V2, and divided by 2 we have already as it is. So what we will be getting, I2 is equal to V2 by 2 if you solve this part. So now substitute that, V1 minus I2, you replace it by V2 by 2, that is equal to 0. So solve this, what we would be getting, if we bring this term to other side, this would be equal to V1 equal to V2 by 2, that is, but we needed V1 by V2, right? So V1 divided by V2, bring this V2 down, here 1 is there and divided by 2. So V1 by V2 is what? H12, that is equal to 1 by 2. So hope this is clear how I solved. I've used this equation first. In this equation I've substituted the value of I3, that is minus I2 by 2. 2 would be getting cancelled, that we would be left with V1 minus I2 equal to 0. But our goal is this I2 we should be trying to represent it in terms of V2, because we have, in order to find H12, we have V1 and V2 terms. So what I've done, I've considered this part. Here I have represented I2 in terms of V2 by keeping I2 in one side and brought this V2 here up. So that would be V2 by 2. That I've substituted here and solved it. V1 by V2 is H12 and we have got. So our final answer of H matrix, I'm writing it here. That is H11 is equal to 2. H12, that is 1 by 2. H21 minus 1 by 2. H22 is plus 1 by 2. So this is our final answer. Okay, so we have solved one problem. I've taken a lot of time, but this problem was very, tricky. So please go through it. These kind of problems would be coming for 8 marks. Okay, you should not be missing any steps. Try to understand the problem and analyze and solve it. So that's all guys. Like, share, subscribe to our channel, share this playlist. Let us see you in the next video.